So okay, in this video what we're going to do is calculate the variance of a hypergeometric distribution. So we're going to say that we have this random variable x, which is hypergeometrically distributed with parameters w, b, n. And I will remind you what this means. It means that we have a bag containing marbles of two colours, w and white and black marbles. So we have, this is the most intuitive, in my opinion, way to think of where the hypergeometric distribution came from. So we have w white marbles and b black marbles. So in this case w is 4 and b is 5 in the picture, but of course it can vary over, you can let them equal whatever you want. And basically we've ascribed to every single one of these marbles to make this this structure easier to handle. What we've done is we've labelled all the marbles. So every marble now has a number associated with it. So this is marble 1, marble 2, marble 3, and you go all the way down to marble w in white marbles, and then you get to the end of the white marbles and you begin with labelling the black marbles. So you label the first black marble w plus 1, and you get to the final black marble, which is labelled w plus b. So basically we have a bunch of marbles going 1, 2, all the way up to w, and then you go on w plus 1, and you go on all the way up to w plus b. And this is basically a nice bigger list of every single marble. Every single marble is in there somewhere. These are all the black marbles over here from w plus 1 onwards, and these are all the white marbles, i.e. From 1 to w. Right, so we then have a probability space, which is which I will draw as a square, a rectangle rather, which contains every possible outcome of picking n of these marbles. And I do not care about what order you pick them in. If you pick marble 1 first and then marble 2, that is the same to me as picking marble 2 and then picking marble 1. I do not care about the order, basically. All I want to know is what number marbles you have picked. I do not care what order you pick them in. So, in this probability space, I want you to put in every possible outcome of picking n marbles. So when you pick n marbles, you could pick marble 1, you could pick marble 2, you could pick marble w plus 1, marble w plus b, basically. So I've just listed off all the marbles that I've got actually drawn on here. Okay, so you pick n marbles though, so the number you have to pick out is n, and you put every possible outcome of picking n marbles into here, but you make sure there are not degeneracies. So I do not want two outcomes which are the same thing but just different orders. I do not want this. So I do not want marble 1, marble w, marble 2, marble w plus 1 and marble w plus b. That is not counted as a separate outcome. That is just a permutation of these. Now, as far as I'm concerned, you have picked the exact same marbles if you've done that. So that outcome is covered by this outcome. What I am interested in is a different outcome, for instance, a marble 3, marble 4, marble w plus 1, marble w plus b. That's a different outcome because you have actually picked different number marbles now. So, you put all of these outcomes into this probability space, and we've seen that you can create this random variable, big X, which is going to ascribe to every single outcome. It's going to ascribe a real number, and it's going to ascribe the number of white marbles you pick, number of white marbles that you pick. So that number can vary from 0. You could actually pick no white marbles, providing of course that the number of black marbles and the number of white marbles in the original bag are greater than the number you're picking. Then you could pick 0 white marbles, i.e. you could pick all black marbles, and then you can go on all the way up to picking number n marbles. Again, that assumes that w is greater than or equal to n and that b is greater than or equal to n. If b was not greater than or equal to n, you couldn't possibly only pick 0 white marbles because there wouldn't be n black marbles to pick. Okay, so you ascribe to every single outcome the total number of white marbles you pick. So in this case, we look at the marbles we've picked. We've picked marble 1, marble 2 and marble w. They are all white marbles because they're all in this bit here. So these are the white marbles. These are the white marble numbers, white marbles. And beyond there are the black marbles. So these are the black marbles here. Black marbles. Okay, so you have picked 3 white marbles in this case, so you would describe it the number 3. Okay, so now what we're going to do is we're going to view this random variable x as the sum of a bunch of other random variables. So we're going to create a bunch of other random variables. We're going to create the random variable, let's say x subscript 1. Okay, and this is going to ascribe you two numbers. It's going to ascribe each outcome a single number, but there are only two possibilities for the number that it can ascribe. It can ascribe you either 0 or it can ascribe you 1, so it's a Bernoulli distribution. Okay, and basically the way it's going to work is it's going to ascribe to an outcome, so it's going to take an outcome and it's going to ascribe it a 0 if the first